In this video, we'll solve a few problems involving calculus of vector valued functions. So let's compute the derivative of the following function. To calculate the derivative, we write it so it's r of t, so r prime of t is the derivative of each individual component. So cosine of t prime is negative sine of t. T squared is 2t, sine of t prime is cosine t, and this is the derivative of the r of t. Let's solve another problem. Again, r prime of t, so this is a vector, right? So it's going to be each component. So I'm going to calculate t e to negative t prime, that's the derivative with respect to t. Because it's a product here, we're going to use product rule. So it's t prime, that's 1 e to negative t, plus t times e to negative t prime, which is negative e to negative t, which means e to negative t times 1 minus t. That's the derivative of this component. Let's do t ln of t prime. Again, product rule, t prime 1 times ln of t plus t times ln of t prime, which is 1 over t. So we get ln of t plus 1, or 1 plus ln t. Be careful, t is not plus 1. It's ln of t, and the result is plus 1. So the derivative of r is going to be e to negative t times 1 minus t. The second component is 1 plus ln t, and the third one is cosine prime of t, which is negative sine t. And finally, r of t is tangent t, cosine squared of t secant t, and we want to find r prime of t. Let's not forget this is vector. Tangent of t prime, so tangent is sine over cosine, so it's secant squared of t. Cosine squared t, it's 2 cosine t times sine t times, it's 2 times cosine t prime, which is negative sine t. So it is negative 2 sine t cosine t, which is actually negative sine of 2t. That's the trigonometric formula. And then secant of t, that's 1 over cosine t, and that prime is cosine t prime, negative cosine of t prime over cosine squared of t, that's sine of t over cosine of t times cosine t, that's tangent t secant t. So here is tangent t times secant t, and this would be the derivative. Let's do this problem. Find the tangent vector as a given value of t for the parametric curve. Well, the tangent vector is r prime of t. So then we are going to calculate the derivative of each of them. So 8t to the third I plus 6 times 3 over 2, that's 9t to 3 over 2 minus 1, that's a half j, minus 10, and 1 over t prime is negative 1 over t squared, so minus 10 over t squared, k. And we want to evaluate this at 1, so we get 8i plus 9j minus 10k, or 8, 9, negative 10. The unit tangent vector, so the tangent vector, it's r prime of t. Well, if I want to find the unit tangent vector, we are going to divide r prime of t to the magnitude of r prime of t, and that gives us the tangent vector. So we want to find the unit tangent vector for the parametric curve. So let's find r prime of t. So this is r of t. So r prime of t is 2, 2, 1. The magnitude of this one is square root of 2 squared 4 plus 2 squared 4 plus 1. So that's square root of 9, which is 3. So the unit tangent vector t is given by 2, 2, 1 divided by 3. So it's equal to 2 over 3, 2 over 3, 1 over 3. Derivative rules. So some important ones that might be new. It's the derivative of the dot product. So we still use the product rule, but we have to be careful that we have dot product between the vectors. And if we have to differentiate the cross product, again, we do differentiate using a product rule, but in between our vectors, we don't have the regular multiplication, we have the cross product. So let's do a few problems. Let's say we have the vector u, we have vector v, and we want to find the derivative of this d dt of t to the 12 plus 3t times u of t. So the derivative would be the derivative of t to the 12 plus 3t times u of t plus t to the 12 plus 3t times the derivative of u of t. So we get 12t to 11 plus 3 times 2t cubed I plus t squared minus 1j minus 8k plus t to the 12 plus 3t in side parentheses times the derivative of u of t, which is, so u of t is this one, and we're going to differentiate each component. So it's 6t to the second I plus 2tj, and then 8 prime is 0, so there is no k component. And we can multiply them, and we have 24t to 14i. So we are multiplying this, and then we can multiply this one as well with I. So then it's going to be plus 6t to the third, and let's do I plus, and now let's do this one times this, and the same here. So it's going to be 12t to 11 plus 3 times t to the second minus 1, and that's times j, and then minus 8 times 12t to 11 plus 3 k, and plus 6t squared times t to the 12 plus 3t I plus t to the 12 plus 3t times 2t j. So if we open up the parentheses and we add like terms, we get this answer. And of course, we could have done this problem by multiplying first this function, this function times u, and then differentiating. So it could have been done that way as well. But I chose to differentiate using product rule. And then I combine like terms, like the yellow ones together, because they were times I, and I resulted in this answer, or this one. And then the blue ones together because they were times j, and resulted in this one. And then the term in front of k, and we got this one. Okay, now let's solve this problem where we have u and v, and we want to find the derivative of the cross product. So the derivative of the cross product is d dt of u cross product v plus u cross product d dt of v. So let's calculate the derivatives. So the derivative of u, so u prime of t, is 6t squared 2t0. The derivative of v is e to t, negative 2e to negative t, and negative 2e to t. So the derivative of u cross product v is equal to 6t squared 2t0 cross product v, which is e to t, 2e to negative t, negative e to 2t, plus u 2t to the third t squared minus 1, negative 8, cross product v prime, which is e to t, negative 2e to negative t, negative 2e to 2t. So now, to find the cross product, I'm going to calculate each determinant. So it's going to be I, j, k, and then 6t squared, 2t0, and e to t, 2e to negative t, negative e to 2t, plus, and the same I, j, k, and then the components 2t cubed, t squared minus 1, negative 8, and e to t, negative 2e to negative t, and negative 2e to 2t. So we get, if we cross out the row and column of I, we end up with negative 2t e to 2t, and then minus 0. Then minus j, now we cross out row and column of j, and we end up with negative 6t squared e to 2t, and then minus 0, and then plus k, and then we cross out, and we end up with 12 t squared e to negative t, minus 2t e to t, plus I, we're doing the second determinant, so negative 2t squared e to 2t, plus 2e to 2t. This was by calculating these two. So I did these two. And then is minus 16e to negative t, minus j, and then we cross out the row and column, then we end up with negative 4t to the third e to 2t, plus 8e to t, and then plus k, and negative 4t cubed e to negative t, minus t squared e to t, plus e to t. So now add like terms, combine like terms, we put together the terms in I, and then the terms in j, and the terms in k, and we get this answer here. Let's solve another problem involving integrals. So let's say we have r prime of t, right, a vector function, r prime of t equals e to t sine of t secant squared of t. We know that the initial condition r of 0 is 2 to 2, and we want to find r of t. So r of t, it's equal to the integral of e to t sine of t secant squared t dt, which means it is equal to e to t plus c1 negative cosine t plus c2 and tangent of t plus c3. But r of 0 is equal to c1 plus 1, c2 minus 1, and c3. But it's also equal to 2, 2, 2. So that means c1 is equal to 1 because we equate c1 plus 1 equals 2. Then c2 minus 1 equals 2, so c2 equals 3. And then c3 equals 2, so c3 equals 2. So in other words, r of t is equal to e to t plus 1, negative cosine t plus 3, and tangent t plus 2. This is the function that we were looking for. And one more example involving definite integrals. So evaluate the following definite integral from negative 1 to 1 of I plus tj plus 3t squared k dt. So the integral is equal to integral from negative 1 to 1 of 1 dt I plus integral from negative 1 to 1 of t dt j plus integral from negative 1 to 1 of 3t squared dt k. So integral of 1 dt, that's t from negative 1 to 1 I plus t squared over 2 from negative 1 to 1 j plus 3t squared, that's 3t cubed over 3, so it's t cubed from negative 1 to 1 of k. So that is equal to 2i, then t squared, that's 1 over 2 minus 1 over 2, that's 0, and then plus 1 minus negative 1, that's 2k. So the integral is actually this vector 2, 2, or it's 2i plus 2k. 2, 0, 2.